If you want to fire that up, I
Okay,
want
Renee?
to see smoke. Where's Sean?
Renee gets to do
He's
the
running.
smoke.
Why do I get those questionable honors?
They want somebody to blame.
That's exactly it.
Yeah, blame it on the foreign guy.
No.
Yeah,
No.
that's right.
How do we set the transmitter, guys?
Well, that's a good one. You
I
said
thought
you,
it was, or I wouldn't have asked it.
well, you said you always test on different frequencies, right?
Yeah, but what do we know about, what are we gonna do with the modulation?
Probably LSB, yeah.
Yeah, what else?
CW would be, CW would be.
Keep going.
CW give you a carrier.
FSR.
FSR.
There it is.
There it is.
FSR, okay, there you go. Yeah.
NFC.
How do you spell that?
We could all learn
Yeah.
something today.
FSK, you can use
It's not for a
FSK.
service road.
Use
like
FSK.
That's people in the map in the area.
Okay,
Yeah.
what's the difference?
FSR?
I
I
have
don't
to
know.
look at what they've done in the radio. Normally it's FSK
Oh, for
on
frequency shift
frequency shift
Shift
keying,
keying,
yeah, and that's full carrier. So now you're ready. Okay, but you can also try it with voice and you can see why you can't read it.
Sorry?
Right.
Would R be relay or frequency?
Frequency
shift?
Shift, frequency shift.
Frequency
Keying.
shifts,
And
then R.
PSK
it
is
could be
phase shift.
reversal.
I see. But FSR is
Yeah.
what the R stand for.
Good
Yeah,
question.
so we're trying to figure out.
Now, the beauty of
Relay?
that is that when
Internet.
you push the mic button down,
Yeah.
you're gonna get a full carrier.
Okay, yeah.
Now, is this set already on 150 watts or so?
Are you
It's already
attached
at
to
the
the
height
right-
setting?
Hold
It's
it.
on 150
And
watts?
make sure you're on the right
Should be
antenna.
How many watts? This puts on 100 watts or 200 watts?
It's
It has multiple outputs.
Okay, so then we
Yeah, it's
should
got
be
one
good.
An
and
amateur radio rig.
Yeah, so we're on 100 watts and.
It's got which thing?
It's
and we're
got
on
two
10
antennas.
watt?
Yeah.
Oh, two antenna ins, 1 and 2.
Power 50 watts or 50%.
Okay.
Oh, where does it say that?
Shoot the juice to it, Bruce.
Oh, yeah. Number one.
And if they
Okay,
smoke,
so
stop.
on the
Looks like
150 watts, yeah,
Looks
we're
like
just,
50 watts, yeah. Put it on full power. I wanna see smoke.
Which one was it? Okay.
I'll be damned. Look at that, eh?
A full output?
well, it's sitting at 775. Now, do you have a correction in this? Is that where?
No,
Okay.
it should be, that's what you're gonna get out
Okay.
of it at the moment.
Okay.
Okay.
Now, key that again and take a look at this needle, what happens?
And it's
Doesn't
not
move.
moving because it's a
Why
perfect.
isn't it not moving?
Right, because
It's a
it's,
perfect match.
yeah.
Okay, Steve, can you turn that around and can
No,
you guys
wait.
do that again? Just so
one
that
more
we get
time
it on
for, with
video.
feelings.
Yeah, with feelings.
It's just way more fun than packet.
Okay, awesome.
There's a lot more.
Cool.
No, but the same thing applies to VHF.
Okay.
Yeah, same thing applies. You've still got the same problems with transmission line. You've got the same issues, you've got the same testing process. Only when you key the mic, you're gonna get full carrier anyway, because it's FM.
Right. I tell people, it doesn't matter how much power your radio puts out, if it doesn't make it out of the antenna, it doesn't do you any good, right?
Well, yeah, in this case,
Right.
that's not gonna radiate very well.
Does it feel any warmer?
No,
Hasn't been
it
on
wouldn't
for
be,
very long.
no. No, that will handle the power. Yeah, if you've got a difficult path, and you're signal's just breaking the squelch, okay? And this will only essentially, well, it'll work on a repeater, but not so well, because the repeater, you've got another, it's a system, you've got something in between. But if it's simplex, which is normally where you run into this, if you know what you're doing as an operator, you'll back off the mic, and the other person should be, if he knows what he's doing, will turn up the volume. And that way, you'll keep the RF voltage amplitude going into your FM receiver as high as you can get it.
It's counterintuitive though.
Yeah, I know it is.
Yeah.
And psychologically-
Just like someone not hearing you, you're going to yell.
That's right.
Or speak louder,
That's right,
so it's counterintuitive.
yeah. But if you know, but it's important to learn that, because once you're aware of that, if everybody's aware of that, that's dealing with it, you can solve a lot of problems. It may be saving a life
Yeah.
if you can do
If
that.
they're down in, yeah, okay.
If everybody's aware of the issues, but they don't teach it anywhere. And I was amazed when I heard that, I asked them that they were teaching the Marine VHF course, and I said,
Your
what are you
RCM.
talking about it? Oh, no, we don't do that. Okay.
And so the simple, the layman's answer to why that is the more amplitude you put into your mic, what is the,
Okay, think about it in that, we were talking the transmitter now, okay? So what happens, and I wish I had a,
Whiteboard right there?
no, I wish I had a, well, yeah, I could use the whiteboard. Let's look at it, and again, let's look at it simply. Now, can we envision the frequency domain?
Domain.
Yeah, because remember, there's two domains that we can deal with. We can deal with the time domain, which is an oscilloscope. Everybody familiar with an oscilloscope? That's in the time domain. We're going into the frequency domain. And so the frequency domain is like this. This will be F, okay? And then we have a carrier, so that'll be at some frequency, all right? So we're talking FM now. So you get on there and you put a 1,000 hertz tone in, okay? So what are you going to see? You're going to see,
When they sign in, okay.
here's what you're going to see. Each one of those is separated by kilohertz, okay? So, and as you increase your voltage, the output into your volume of your voice into the mic, you're going to see this. Same thing. Right? What's happening? It's getting smaller and smaller and smaller. And it's going to get wider.
it's spread out?
Yeah, it's going
Right.
to spread out. Because you still got
Whatever.
50 watts if that's your transmit output, but you're covering a greater bandwidth. So this here is RF voltage. This is RF voltage. Maybe better to put that up a little higher. Okay. So the greater the signal that goes in, the more energy is going to go into the side frequencies, okay? And the lower this RF voltage is going to be at the receiver, okay? This is at receiver. Okay? Did that cover it? Don't look at me like that.
I was looking.
That makes a lot of sense.
Yeah, it makes a lot of sense, definitely.
Yeah. When I started this out, I said it's got to be intuitive, okay? It's got to be something that you feel, you have a gut feeling for. If you're ever going to do anything with it, it's got to make sense to you, and it's got to be, you've got to be comfortable with it. So if there's any questions, just keep going. There's no such thing as a stupid question.
Just stupid people asking questions, no.
No, it's stupid people that don't ask questions.
That's right, that's right.
Yeah, I was reading
Yeah.
on super narrow modulation, because right now we've migrated from, 25 kilohertz bandwidth down to 12.5. Now there's coming out as 6.25. And that was what, on the Kenwood website, you can go to the site and you can see like what the advantage is. And of course, they're saying that there's a lower signal to noise ratio on 6.25.
You improve the signal to noise.
Yeah, it's
Because
super
again,
narrow.
what are we doing?
Less bandwidth.
Less bandwidth. Less bandwidth is
Less noise.
lower noise. Okay, that's all I want you to get out of this. Okay.
That's huge, though.
Besides
That's a
putting
huge
more
thing.
frequencies in the same space, or more
Yeah.
channels in the
Well,
same
yeah,
space. That's the other
I mean,
goal.
that's fine, but
Yeah.
what we're talking about is essentially a situation where in normal operating conditions, which is what we're talking about. I'm not worried about whether they get 400 channels in there or not,
Right,
and neither are you if you're using it.
right.
But if you're using it, you need to know this for
Well,
FM.
And from an emergency comms point of view, I mean, it's critically important because obviously we're not
No,
going to
it's
get our
critical.
message across if we're just splattering all across the
Well, you won't
frequency.
splatter because again, your FM transceiver has a built-in
Modulation.
circuit that will reduce the deviation.
Right,
Okay, but you can still end up getting distortion,
right.
because once you overdrive that circuit, then you're gonna create distortion. You won't see any real difference out of the transmitter, except that you're gonna see the distortion. But then what you're doing is you're transmitting distortion, because the distortion is taking place in an earlier part in the deviation circuit itself.
And people still won't be able to understand you,
Yeah,
which is all we care about at the end.
yeah. So if you can remember these few simple things, you're gonna be really good with VHF or UHF.
Excellent.
And remember the basic thing with single sideband is, output power is,
Dependent on the input voltage.
input, what voltage? Audio voltage.
Audio
Voice
voltage.
modulation.
Yeah, yeah. And remember too, that all receivers are voltage devices. Transmitters are power devices. And that can really screw you up. And that can screw you up right here.
Yeah,
Because if you think about the FM receiver as a power device, you're in trouble, my son. It's not. You've got to know that it's a voltage device, and therefore, if this happens, signal goes down, and hey, where are we? We're out to lunch. All clear? Have we
awesome.
covered FM, single sideband? Well, we can talk about grounding very quickly.
Okay.
In your ground plane.
Ground plane.
Well, you're talking about yeah, if you're talking about a counterpoise.
So- I guess it all relates, it's always gonna relate back to my packet kit that I play. It's a
Wait,
bad-
isn't that the SRD packet? Never
Yeah,
mind.
sorry, yeah, correct.
It's a simple antenna issue. Whether you're dealing with packet or whether you're dealing with HF or you're dealing with anything else.
Sure.
It's an antenna issue, particularly vertical antennas.
Okay.
And so essentially, a vertical antenna is half of a dipole. Where's the other half? In the ground plane.
Okay.
So if you've got a good ground, then it replicates itself in the ground. So it's essentially the full dipole then, and that's how it works.
Okay.
So vertical antennas can be quite cute like that. They're omnidirectional, as you know,
Yes.
and if you don't have a good ground plane, it's easy to do at VHF. Really easy to do, because you just put out some,
Radio.
and it only has to be quarter wavelength to do it correctly.
Okay.
And in fact, there used to be, I haven't seen any of them around, but I used to have an antenna that had a ground plane on it, but it was on essentially a tube that slid up and down. You could tune it.
Oh, cool.
And you can make those things, they're really easy. And what you do is you have the quarter wave or 5/8 on the center, and on the ground of the coax, okay, make up a little round insulated piece. You put your coax connector on there, okay. You connect your radio, your transmit antenna on there, and then you take the coax to ground on the sleeve of this, and it's cut to a quarter wavelength. If you get two of them that slide inside each other, right? And what you can do then is tune the SWR for whatever frequency you want. It's a sweet deal, and it works like a hot damn.
It works really well on that specific frequency.
No,
Oh.
all across the band.
Oh, okay.
And the big problem you have with a lot of those antennas is that they don't work too well at the band edges. Well, with this, all you had to do was you had a little pipe clamp, hose clamp on there, let it out, and watch the SWR meter. Okay, bang, game over. Some sneaky things you can do with VHF, guys.
Sounds like a worthy experiment.
Yes.
Yeah.
And cheap to make.
Yeah.
You just go down to metal supermarket and get yourself a couple of pieces of aluminum tubing that will slide inside each other.
Yeah.
Use that for the outside.
Yeah.
And if you've got, make yourself a little, plastic thing about 3/8, half an inch thick,
Yeah,
and that will fit into the tubing.
yeah,
Screw it in, tighten it, and then connect the ground of the connector on top, the coax ground,
yeah,
to the tubing,
yeah,
and the center to your antenna element,
easy peasy.
and then you can side that thing up and down and tune the.
Instead of having actual radials sticking out, you just got the tube.
That's right. We used to
Okay,
have
we got a project.
We used to have
This will be
mobiles
fun.
like that.
I was gonna say, unless.
Mobiles like that
Yeah.
on a string mount.
Yes, then.
Yeah,
They work like a hot
we'll
damn.
make this a project.
People say, why is that thing putting out such a good signal?
Is there a need for this device?
It's a coaxial collinear antenna. Coaxial
How long the tubing do you need?
Quarter wave.
So, okay, yeah, sure. Not that long.
No,
Coaxial.
VHF. That's cool.
coaxial collinear, yeah.
And that's on VHF only, it wouldn't work on HF.
Well, HF it'd have to be really, really long.
Yeah.
You're gonna need a big antenna, my son.
Better off like using the ocean
Yeah,
or wet ground, you know.
and we talk about ground, so there's the other thing that they wanted me to mention tonight. And one of the issues with grounding, and a lot of people, there's a couple of issues here that you wanna think about. Quite often, people use that braided cable.
Mm-hmm.
Now, that works really well as long as it doesn't corrode.
Okay, does everyone know what we're talking here? Because we're talking about two different kinds of grounding here. We've got ground planes on antennas, and
And
then
we're talking about grounding the antenna, we're talking about running a ground off your radio.
so this is
Or off your
DC
tuner.
grounding.
So, no,
No.
let me finish.
Yeah,
We're talking about DC and RF,
there we go.
okay? And so, a lot of people get this flat
Strapping.
strapping that's made up of multi-wires, okay? And say, well, hey, that makes a good ground. And my answer to that is yes, for a while. Until you get a little bit of corrosion between those little wires in there, and it forms diodes. And everything goes into the dumper at that point. The only way to do a decent RF ground, you can't use a piece of wire, can you? What happens to a piece of wire at RF?
Antenna.
It becomes inductive, it becomes what we call reactive, because it has inductance and capacitance in it. So it doesn't make a good RF ground. If RF looks at that, it sees a resistance. Sees a reactance, which is in terms of RF resistance, okay? So it's not a good RF ground. If you want an RF ground, I've got, funny you should ask.
Foil.
That will be non-reactive to an RF signal.
That's expensive.
No.
It is, it's copper. It would work better if it was gold, but it'd be more expensive, okay?
Well, no, it's really, really thin.
So, we've got to think about these things when, again, this word let's look at something simplistic and try and visualize a wire, a normal wire with RF signal fed in at one end. What is going to happen? Think of it as a transmission line. And that's what you should do. Think of it as a transmission line. What is it? Model it in your mind. Yeah? That's good. Think it looks like an antenna.
Sure.
Yeah? And what do we know about antennas?
Oh, yeah, the resonance.
Radiate energy, okay, well, the one other thing I'm looking for here.
You pick up energy. RF.
We want to make certain that it has zero resistance.
Right.
Zero RF resistance. So if we use the wire, what's the wire going to have? If we make a lump, if we draw a little circuit for that, what are we going to see? Well, this is what we're gonna see, guys. Where's my, did I take it? Did I lose it? I didn't eat it, so it, oh, there it is, yeah. Absent-mindedness is a sign of genius. So this is a real trouble. A single wire
Gotta use that.
at RF is gonna look like this.
Resonant circuit.
What do you think RF is gonna see when it looks at that? Or, from an RF standpoint, this is what the RF sees.
Resistance.
Is that a good zero loss path to ground? Ah,
So, sorry, pardon my ignorance, where is this RF ground in your system?
in the system? Well, it's gonna be at the ground, in the ground itself, at Earth. If you're out on the water, it's the ocean,
Okay,
okay? Which is, the ocean's an easier one to discuss because it's a perfect ground.
Where are you connecting it to your equipment? I think that's the question.
To the ground.
But
Like
on
your
on
radio.
the equipment, okay, so to the actual ground terminal of your
There's a
radio.
ground terminal on your radio.
The case, like the casing of your unit?
There's be a ground terminal on your radio.
And sometimes it's actually on the outside, but.
Now, I'm not certain with that radio, but every radio, every HF radio every radio should have a ground connection on it that goes to the chassis and to the internal grounding of the radio, okay?
Okay, so this is for right here. The
GND. And again, RTFM, and it should tell you where that is, okay, in the manual. And so that's where you're gonna connect it. And so, a lot of people on boats have a problem because they ground everything directly to the ocean. That works really well, but what does it do? Screws up something else, corrosion. You get cathodic problems because you then get a DC current path and it'll go through the metallic object on the boat, and it'll create a problem with the cathodic corrosion.
And this is especially fun when you have an aluminum boat.
So, or aluminum is really bad, and
Yeah.
steel is there as well. So, can you get around that? Yeah, sure you can. Sure you can. What you do, something like this, here's your radio. Here's the ground connection, right here, okay? So we're gonna connect this to a ground. Let's assume it's a perfect ground. I mean, it could be ocean or whatever, okay, we don't care. And let's assume that it's a boat, let's say this is water. Plus salt, right? Okay, and you know. So what we're gonna have then is a flat piece of copper that's gonna go to the ocean, okay? So we say this is not good if we're gonna have, because we don't want a DC path through here, right? If you get back into equipment and stuff. Because you've got a DC ground on a boat as well, which you don't want. So this is actually a good thing to think about grounding. So what we do is, let's redo this. There's our radio, there's our ground. And so what we do is we put a little piece of copper, and we put the rest of the copper on here. And over here, we put some 0.001.1 microfarad capacitors. That stops the DC. As far as the RF goes, the RF sees it as an open, as a short. So you stop the DC, and you let the RF go through. That's an RF ground.
that's what's on the back of the radio, it's an RF ground, it has nothing to do
You
with.
want, you want a DC and an RF ground.
Yeah.
But what I'm telling you is to be careful when you do that. If you do it on a boat, be careful with this, okay? If you're here, what you want to do, let's say in this building, and you wanted to run a really good ground down,
Mhm.
you want to put foil down to a really good ground rod driven into the ground.
Foil, flat,
Yes,
flat.
yeah, because this is non-reactive. The minute you get into wire, it becomes reactive, and this is what you get.
It's round, the shape of it?
No, the wire itself becomes that,
Right?
because the RF signal sees a wire. And if you remember that your lines of force build up around the wire, like so, and as the frequency goes up, okay, you start at DC, and it's a pure resistance. As you go up in frequency, you start to get inductance and capacitance happening,
Okay,
okay, which is, we term this reactance.
okay. I guess what I'm asking, what's the difference of physical property between wire and flat? That's making
This doesn't allow the signal lines of force that are built up around this are totally different from what's found but around a wire.
Okay.
Remember, a wire carrying a current creates a magnetic field,
Yeah.
right? And that's the whole inductance
This will
thing.
create a
There's
magnetic
no
field.
magnetic field off of a
Okay. So that's grounding, okay? Are we
And how wide is the,
to it this? Well, it's the old story. People say to me, how wide should it be?
yeah,
I'm saying, well, 6 feet. Oh, we can't do that. So, hey, everything's a compromise, right?
okay.
So,
So
we
you got the
have,
second story up here, like,
yeah,
if you're gonna go down 20 feet with that much,
yeah, it's gonna cost a few bucks, but if you're putting in a radio system, what do you want it to work or not? It's the same thing I tell people with the Packer modems. You want something that's gonna work, or do you wanna play with one of these other things that they're using?
okay? And the quality of the ground, what is that at the end of the day, what is that?
Well, that's another issue, and remember that ground changes depending on, the primitivity of the ground changes depending on a whole pile of things like water, moisture content,
Sure,
elements that are in there, and you can actually measure that.
Okay.
It's an old device. Do you know what a megger is?
Yeah, I've got one in the truck.
I've got one as well. You ask anybody today and they won't know what a megger is.
Super shocking your friends.
What is a megger? Can you just explain
You
it?
know what the old, game, you don't.
It's a brand name.
You're too young. The old mag phones? You ever seen one of the old mag telephones?
Oh,
Where
the
you
magneto
crank
ones. Yeah, absolutely. Yeah. Bill over in Sayward actually has one. Just the
Let me
working
tell you
part.
something about a mag phone.
You know, they can be exciting.
To date, they have not designed anything that has better audio characteristics than a mag phone.
Really.
Good music.
And what you're doing is, that's a magneto that you're
Yeah.
cranking to produce the voltage. And a megger is exactly that with a meter on it. You create a hell of a big voltage that you can fire through things, and it measures resistance.
So in other words, when you're doing this into the ground, make sure you have good rubber soles.
If you're, well, we used to meg out grounds, you probably did the same thing.
Well, that's what I use it for, is checking bad coaxes, because you can't, with a watt meter, you know, the antenna might look good, but, you know, I measure a coax, and, you know, a megger generates 500 to 1,000 volts, and in theory, a coax is two lines, you know, separated by insulation. If there's any resistance in it, you know,
You'll
you're
get a-
generating 500 or 1,000 volts, then
You'll see a
you'll
resistance
see a
reading.
resistance. So what's the thing about copper braid? It's a wick.
Yeah.
So all you have to have is moisture wicking slowly down your antenna coax, and now your characteristics of your coax has changed, right? Put that on a vehicle and it's shaking like this, or squeeze between the hood and the fender, and now your coax has changed shape too, right?
Yeah.
So you measure it, if it's not, you know, if it's not infinity, then it could be any value towards up to a short. So you can check if you've got a bad coil, and like you were saying, is that a shorted coil looks great on a watt meter. You're putting out 50 watts, you also could be getting back, you know, reflected. So the megger will tell you if there's any resistance in the coax, because it shouldn't be, right? It's a wire inside of insulation.
We're
protected
talking
by a
old
braid.
school here now,
Yeah,
guys.
But, you know,
Cool
yeah.
though.
That's cool. Yeah.
Totally cool.
So, yeah, so it's, and the other thing to remember with coax, while we're talking about coax, do not buy coax that has the foam core. Do not buy that stuff, because it's hygroscopic. And if
Ooh,
water can get in at all, believe me,
Wicked.
yeah.
use the real good poly, the real solid poly. And you can suffer a fair amount of water in that without any problem. Also too, all wiring to do with antennas or anything else that's gonna be in the wind, stranded copper, do not use solid copper. Again, from the same thing, wind moves anything solid and it's gonna fatigue and break. I've got antennas that we put up 5 years ago on the Euclid Fire Hall, and that antenna's been there for 5 years through everything, and it's had not given a little bit of problem, not a lick of problems. I used number 14 stranded copper wire.
This is an NVIS antenna, right?
That's an NVIS
Okay.
antenna, yeah.